Okay, grab your notes, please. Let's talk some applications here. So yesterday we talked about one application in matrices, and that was cryptography, coding and decoding. Today we're going to talk about other ways to use them. We're going to talk about Cramer's rule. I'm going to tell you what it is and how to use it to solve systems. We're going to talk about how to tell if points are collinear and finding the equation of a line. Okay, so let's talk about Cramer's rule first. Here's the process. First thing we do, we create a coefficient matrix. Second, we create an X and Y coefficient matrix. Third, we find the determinant of each. Fourth, we use Cramer's rule to solve. I just want you to write these down, and then we work through these steps in the process of a problem. On a side note, while you're writing this down, I have decided that I'm going to move the test back a day. Okay, I'm sorry. So we're going to do it Friday and Monday instead of tomorrow and Friday. I hope you don't forget. AJ?
Is it a two-part test?
Yes.
So we have a project and one part and a two-part test?
Hey, the project's easy, bro.
Yes.
Well, obviously, yeah, it's like a free.
I'm trying to give you lots of points opportunities here.
Yeah, so.
One part is calculator, one part is non-calculator. So Friday we will do the non-calculator part. Monday we will do the calculator part. No, you cannot start it early. No.
Oh my God. Oh,
Okay, everybody got the steps down? I'll give you a minute longer. They're also going to be on all the screens, so it's okay if you don't get it. Yes, you can. Okay, step one. We're going to create a coefficient matrix. So what we're going to do is we're going to take all the coefficients and we're going to pull them out and create a matrix with them. And we're going to find the determinant of this. So remember we cross multiply, so we get 6 minus 20 is negative 14. Okay, so we pull the coefficients out, make a matrix, and then we find the determinant. Everybody with me so far?
So we're just leaving, we're just putting in, we're bringing out the numbers.
Okay, now we're going to create an X and a Y. To create the x, we're going to replace the x coefficients with the answer coefficients. Oh. So the 2 and negative 4 become 3 and 8. Do you see what I did there? I took the answers and I substituted them in for the x's. I took the 3 and 8 and I substituted them in for the 2 and 4. Nope, column. Yep. For the 2 and 4. For the x, yes. And then we're going to do the same thing for the y. So to create the y, we're going to replace the y coefficients with 3 and 8. Okay? So we took the last one. I'm going to flip screens real quick. Just sit tight. We took this coefficient, the 2, negative 5, negative 4, 3. We replaced x with the answers and then y with the answers to create 2 new matrices. One is x, one is y. And then we're going to find the determinant of them. Yes. These are 2 by 2s. Pretty easy, right? Yeah. So what's the x? What's the determinant of x? 49, right? 9 minus negative 40 is 49. What's y? Okay. 16 plus 12 is 28. Yep. And that actually was step 3, was to find the determinants of all of them. So the first one was negative 14. The x was 49. And the y was 28. Kramer's rule tells us that x is equal to dx over d and y is equal to dy over d. So I'm going to flip back a second. So to get x, we're going to put dx over d, 49 over negative 14, which is negative 7/2. And to find y, we're going to put dy over d, so 28 over negative 14, which is negative 2. So the solution for this system is negative 7/2, negative 2. So we talked about last unit, we talked about elimination, substitution for solving. This is another way to solve a system of equations. It's probably a little excessive for a 2 by 2, but bigger ones, this is actually a lot easier than solving for 3 variables, 4 variables. Remember doing that with substitution and it took forever? This is a little bit easier and quicker. So you set up 3 different matrices, find the determinants, and then x is dx over d, and y is dy over d. Let's try another one. Yeah. This is Kramer's rule, by the way, if you want to write that down too. And so then let's say you had a 3 variable. Z would be dz over d. W would be like dw over d. Whatever you're doing, okay? Whatever variable. This is Kramer's rule, yes. Okay. Can I move on now? Are we good? Okay. Okay, the last slide was this.
Oh, okay. Yeah.
And then this is just Kramer's rule, so you know what it is. Okay, let's try another one. Let's start with our first one. So this one, we're just going to pull out the coefficients. So 4, -2, 3, -5. And then what's the determinant of this? Thank you. Guys, what's the determinant here? Okay. -20 plus 6 is -14. Be careful about your signs. Remember that it's left minus right. It's left minus right.
So now we do like.
So -20. Let me write this down. Minus -6 is -14.
So now we do.
Now we do x.
X 10, 11, or 10.
Uh-huh.
And then the 2.
And then the -2, yep.
That's so simple.
Okay, now we find the determinants. -50 minus -22, or plus, is -28, yes? Okay. And now we do y. So we're going to go back to our d, right? This time replacing the -2 and -5 with the 10 and 11. So is everybody seeing where these three determinants are coming from? Or three matrices? Okay. And then we take the determinant, 44 minus 30 is 14. Okay. How do we find x?
We do -28 over -14.
Very good. -28 over -14, which is 2. Y is not 1, -1. Yep. 14 over -14 is -1. So your solution for this system is 2, -1.
Oh, the first determinant, like the first one you put right up there.
Okay. Are we okay?
Yeah.
Any other questions? Are we good about the process? Okay, let's make it a little more fun. Let's do a 3 variable. What's that?
I need help.
See if you can set up the first determinant.
Okay, so what does this mean?
Choose a coding matrix. So choose a 2 by 2. It can be anything as long as the determinant is not 0 of it. So you can use any coding matrix you want to.
What does that mean?
Like pick 4 numbers to make your coding matrix.
Oh, and then just multiply them, and then
Mhm.
if it's 0, then I can't use that one.
Correct.
Okay. And then so this is just saying pick it,
Mhm.
and then this is saying multiply them,
Mhm.
and then this says I get my new encrypted message, which will be like formatted like this. I'm assuming.
Correct. And then you'll list them all out on the front.
Okay.
Yeah. Okay, how'd we do? Did we all get that 0 in the middle?
Yes.
Good. There's no y, so we have to put a 0 for it.
Get it? Get it?
Now, this is an application, so you do not have to find this determinant by hand. You can do it with a calculator. However, if you want the extra practice, go ahead and do it by hand.
It's a good question. How do you do that? How do you do it?
10 question mark. So remember, you enter this as your matrix, and then you go to the matrix menu, choose math, and the first option is the determinant. Please check my math, make sure I did it right. Okay, so now we're going to create an X, which means we're going to pull that first column and we're going to replace it with the 102.
Can we do practice yet? Like homework?
And then we're going to find the determinant of this one. I think it's 8. Again, please check me. Okay, now we're going to create a Y. So we're going to keep all of the coefficients the same, except we're going to take out that middle column and replace it with the 102. So notice I'm going back to that original one and I'm just replacing whichever column. For Y, I'm replacing the second column. For Z, I'll replace the third with that 102. And then we're finding the determinants. Negative 15. Yeah. Someone confirm that negative 15 is right for me, please. Thank you. And now we're going to do a Z. So we're replacing the third column, the Z column, with the 102. So negative 16, I think. So the nice thing when you're doing this, if you're using your calculator, which you can, put in the first one, and then you can just go in and change the columns. You don't have to re-enter the whole matrix. You can just change the columns. So that's kind of nice. And then take the determinant again. Is negative 16 right, guys? Okay. Thank you. So let's start with our x. How do we find x? We take 8 over 10, which is 4/5. Yep. How do we find y? Negative 15 over 10, which is negative 3/2. And z, negative 16 over 10, which is negative 8/5. So the solution for our system is 4/5, negative 3/2, negative 8/5. Think about when we were solving 3-variable systems with substitution or elimination. This would have been an ugly answer to get to. Right? It would have been a lot of work and kind of a mess. So Kramer's rule makes, especially 3 variables and up, a lot easier to do. The one thing I would tell you is be really careful about how you're entering it. Just make sure you're entering everything correctly in your calculator. Okay, how are we feeling about Kramer's rule? Good so far? Okay with it? Okay. Let's talk inverses. You can also use inverses to solve systems. This one is kind of fun. I like this one. We're going to do kind of the same thing that we did with Kramer's rule, okay? We're going to pull out the coefficients. But we're going to create a variable matrix with our variables, and they just go right in order, x and y. So let me pause for a second. Think back to multiplication. When we multiplied, we did rows times columns, right? So if we multiply this out, we get 4 times x minus 3y. See how it's 4x minus 3y? And then we get 6 times x and 9 times y, 6x plus 9y. Okay? So we're not changing anything. We're just rewriting this system with matrices in a different way. Let me erase all my lines here. Too many. Okay. Now we're going to say that this is equal to our answer matrix. So pause for a second. Do you see how I got these matrices from the problem? Yeah. I'm kind of just organizing the system in a slightly different way. Yeah. Now, we talked 2 days ago, maybe, about inverses. And we can solve an equation. If the first one is A and the second one is B, we can solve the equation by taking the inverse of A times B. So if you grab your calculator, enter the 2 by 2 as A. What is negative 10, 12? What are the dimensions? Guys, what are the dimensions of the negative 10, 12 of B? 2 by 1. Yep. And then we take the inverse of A times B. And we get negative 1, 2. Which means that x is negative 1, y is 2. That's our point. No. No, thank you. Don't you wish you knew this when we were doing systems?
What?
Would have made it easier, right? If any of you are thinking of going into some sort of mathish career later on in college, you'll take a class called linear algebra, and it is a ton of matrices, doing this kind of stuff with matrices.
What kind of math career would that be?
Computer programming would be a big one, or any kind of like information systems, technical. I think some business degrees require it, and then anything math heavy, like math teacher, engineer, architects, those kind of things. But of the quote hard math classes you take in college, this one is actually, it's pretty fun. Like, it's not super hard. Okay, we got 2 by 2 down. Let's try a 3 variable. Start with your coefficients.
And then it disappears and it looks so sad. Actually, no, I hate
Yeah.
Why is there 2 X's in the middle?
Oh, good question. That's supposed to be a Z. Sorry. That's just a typo. Good catch, Julian. Thank you.
That was on Nike. Thank you, Julian. There it is. Thanks, Rita.
Good job, you two. See what happens when you sit in the front? Your brains are just firing on all systems.
What does that mean?
There, no!
Okay, now check yourself and make sure you got it set up right, and then go ahead and enter these. Remember, the first one is A, and the second one is B, and then you take the inverse of A times B. Yes.
So this is the second method?
Yes.
So we can pick whichever one we like?
No, I will have you do one of each.
It comes from the answers on the Stop dancing, furry.
Oh, what?
Please.
Okay, do we get 2, -3, and 1? No, Jose? Okay.
And then it's
Inverse of A times B. Okay, did we do okay with this one? Try a 4 variable.
I want to make sure I get this done before you leave. It's like I'm worried about it.
Yeah.
So this, right?
Uh-huh.
Is this literally just me? Okay, that's not the right button. Doing this, which is this,
Mm-hmm.
times this.
Mhm.
Okay.
Yeah.
Oh wait, I didn't put times.
Well, that would be helpful.
Okay. And then I get this.
Yep. And then see that arrow? If you arrow off of this, but you can arrow down and see all of your numbers. Make sure you got all of them.
Oh my goodness.
It's a long one. Well, it's going to be the same size as this one.
It looks longer.
I think so.
Oh no, it isn't. Cause it's
Yeah.
one at a time.
Yeah.
Okay.
So then that's what you're going to put here, and then you're going to write them all out in order. I don't care if you do it there or if you do it here.
So wait, how should I write them out in order? Should I write them like long ways?
Yes, so like how you did this one to 18,
Mhm.
do the same thing. Write them in that same order.
So you're gonna copy this matrix out here.
Yeah.
But doesn't that go here? And then how I
Yes.
wrote it, like here, would
Yes.
will go
Yes.
here? Okay. All right, I think it should be the last time.
Okay.
Like, look at it.
Someone scared a man.
No, I'm not. I'm contrary.
What do you think this week is?
I would say he was going to lose 10 times.
Yeah. Dude. I get in trouble for saying Riley Thompson.
Yeah.
Boy.
There's no one to say, hey,
Okay.
what you said to me is a lot worse than calling me a boy. I'd rather be called a fat boy than someone that I don't know about that.
Oh.
Big kick out. You're not touching that.
I'm on my bill.
I think my mom would joke.
Hey, what did you get? This is what you got.
That's not bad.
You want a bed? Ryan, you know.
I think she
She
would sacrifice me to her dog.
They're not real.
No.
What's it about? Easy, it's one pound.
You're going to dark web.
He was the one who
Give up and don't do it himself.
Okay. Here's what I got. How'd I do? Can you imagine having to solve this by hand and find these answers? Say, like, if your evil math teacher gave you this problem before you knew how to do matrices, which I didn't. Yeah, you're welcome.
There was one like this he did.
Yeah, but it had like more integer answers.
How do I do it? How do I do it? How do I do it?
So you take all those coefficients, right? 2, -3, 5, 1, etc. And then you create a 4x1 with your answers. Yep, and then you take the inverse of A times B.
Oh my god, I love you, Al.
So then the first one is A, second one is B, etc. Okay. Are we feeling good? A, about Kramer's rule. B, about solving with inverses. Okay, let's talk about another application, which is finding the area of a triangle, given 3 points on the coordinate plane. We kind of did this already, right?
Yeah, that's right down.
That's the formula. I don't care if you write it down or not. It's up to you.
Will this be a question on the test?
Uh-huh. So remember, when you set this up, you just put the points in for X and Y, and the third column is all ones. Then we take the determinant and multiply by 1/2, and then make it positive, because area has to be positive. This is a calculator question, so this will be on the calculator portion of your test. I do expect you to use a calculator. You do not have to do it by hand.
Yeah, I just do is put in the 1 0. I mean, there's already a 1, all 1 on the right. Just put the points.
Oh, yeah, exactly.
So you can actually type this whole thing right into your calculator. If you enter this, I just entered it as A. It doesn't matter, but yeah.
What's the plus and negative?
So when you plug this all in, you get negative 1.5. But area can't be negative. So the plus or minus tells you to make your answer positive. Okay, everybody remembering how to do this? I want you to try another one. Find the area of this triangle. I just gave you the points this time. So set up your determinants.
0, 1, 1, 2, 2.
So then take 1/2 times the determinant of this matrix.
You haven't written a single thing down.
I went on the right.
What did we get? Zero? Everybody got 0? Okay. How can a triangle have an area of 0?
It doesn't exist.
It doesn't exist. Why?
Because it doesn't close. Or no, it goes on forever.
Forever how?
I don't know.
Okay. Let me show you a graph of these points. It's a line, right? The 3 points are what is called collinear. They are on the same line, meaning they create a, I'm air quoting, triangle with 0 area because they're really a line. So collinear points will have a determinant of 0. That is a very important piece of information. So let me say it again. Collinear points will have a determinant of 0. AJ?
I call that a collinear triangle. Or just say it's collinear.
Collinear. Collinear triangle would be kind of an oxymoron.
There'll be no notes on this test, right?
Correct. Now remember, it is in 2 parts. So like everything we did today would be on the calculator portion. So my suggestion as you're preparing for your test would be to maybe focus on the non-calculator stuff for Friday, and then over the weekend, focus on the calculator stuff for Monday. Okay? All right.